Like, what kinds of things would you like people to work on in your ecosystem?
If you're a dev and you used Ethereum or a L1 blockchain in the past and you feel like I could use more computing power to do X, Y, Z, and this can be whatever you want, right? I want you to be able to explore that. I want you to see what you can do with more computing power on a blockchain network. That's something I'm really interested in.
Hello and welcome to another episode of Devs Do Something. Today's guest is Henri from StarkWare. Henri is a developer advocate at StarkWare who is deeply plugged into the StarkNet ecosystem and also hosts the StarkNet team's podcast. This episode is meant to be a great introduction into building on StarkNet for existing Web3 devs. We went deep into all things StarkNet and Cairo. So we discussed things like the StarkNet account model and runtime environments, the evolution of Cairo and Cairo 1.0, and the future of applications that might use StarkNet for privacy-preserving applications rather than using the ZK rollup for scalability by itself. We also made sure to talk through the mental models that devs coming from the EVM need to understand in order to build on StarkNet, and why the team built their own separate language in the first place. So again, we hope this serves as an excellent introduction to the StarkNet ecosystem, and I hope you enjoy. As devs, we all love hackathons. They're a great way to boost your skill set, meet other engineers, and add to your portfolio of work. At Superfluid, we've sponsored many hackathons and decided to start putting on a hackathon of our own, the Superfluid Wave Pool. This hackathon is a little bit different though in that it's continuous, it's always open. You can submit any project built on Superfluid at any point throughout the month and have a chance to earn thousands of dollars in prizes depending on how your project stacks up. In just the last couple of months, we've seen dozens of teams build really amazing projects that run the gamut from Superfluid developer tutorials to full-fledged applications to a proof of concept, Superfluid StarkNet implementation that we thought was really, really impressive. So we encourage you to check it out today. You can learn more by going to superfluid.finance/wavepool. That's superfluid.finance/wavepool. Happy hacking. All right, we are here today with Henri from the StarkWare team. Welcome.
Hey, Sam. Thanks for having me.
Yeah, of course. We're super pumped to go super deep on all things StarkNet. This is one of our first, if not the first, deep dive into ZK Tech podcast. So we'll be doing more of these over the next month or two. But super excited to dive into all things StarkNet. But before we do all that, the first question we ask everybody is how they got into this industry. So Henri, how did you get into crypto?
Sure. So the first time I heard about crypto was during when the Silk Road made headlines. Basically, I was like, oh, wait, there's a place where you can do all of these illegal stuff. That sounds fascinating. And I remember opening Tor and going on the Silk Road and showing to friends at university, hey, check this out. This is wild. And my friends would say, whoa, but how do you pay for this? You must be traceable or something. And I said, nah, they pay with something. It's called Bitcoin, but it's just something for speculation. Nobody uses it and it's useless. So I kind of just dismissed it. And I forgot about it. And then a few years later, I was in another class and one teacher mentioned, and then there's blockchain. So maybe these are new coordination tool for crowdsourcing stuff. I remember thinking, wait, I like this teacher, is smart, but all of this thing is bullshit. But I have an engineering degree. Let me check why this is bullshit. And it wasn't. So I spent some time actually trying to figure this out. And I got really interested. So it's something I cultivated on the side for another few years before I joined the industry. So initially, I got in through consultancy for a traditional Web2 company. So I worked for two big insurance companies for more or less 4 years, doing POCs using blockchain. And for the second one, I worked on on using how do you use a blockchain as the backend of an insurance company today, which was quite interesting. By the time I left, we had the 500,000 insurance policy in a Geth fork, basically. And then I joined StarkWare. Um, I had heard about ZK rollup in the past and zero knowledge stuff. I had a very general understanding of them. And when I got closer, I was like, oh, wait, this solves actually a lot of problems that are really interesting. And I got more into it, got into the team, and now I explain to people what StarkNet is and how they can build cool stuff on top of it.
I love it. I love it. So this episode is going to get probably progressively more technical as we go, but let's start like a little more high level, right? So it's your job to explain what StarkNet is to people. Give our listeners, for people that are new to ZK rollups, this is a technical audience. Everyone's going to be a dev here, but like what is StarkNet at a high level, and then we'll break into some specifics.
Sure. Maybe let's start as like what problem do ZK rollups solve? And the basic problem of scalability in the blockchain world today is that you want to have a unified version of the world. Like you want everyone to have the same vision of what the state of the system is at any given point in time. And the only way you have to do that is to basically redo all the computation everybody has done before you, right? Don't trust, verify. The only way to get the proper UTXO set of Bitcoin is to replay all Bitcoin transactions. The only way to have the proper state of Ethereum is to replay all the transactions in Ethereum, right? There's no way around that. And so this basic postulate inherently limits what you can do with a blockchain, because you need any player you want on your network to be able to execute the full load of the network, present and past. So this means that if you want your network to include as many people as you want, you probably want them to be able to use a retail PC. And the question boils down to how many transactions do you think you can process on your laptop? And the answer is probably about as much as Geth can do. And the higher load you ask your blockchain, the more people you exclude from it, and the less decentralized it is. And that's basically the problem of blockchain today. You need everybody to redo the same work. Often, some people say, oh, blockchain is distributed ledger. It's not a distributed ledger. It's replicated. Everybody does the exact same work. Now, where ZKs come in, or better said, validity proofs, we can dive back into that in a sec, is validity proof is essentially a cryptographic tool. You can put it in the same mental toolbox as you would hashing function or a signature algorithm, right? You can dive into how they work and look at the mathematics behind it. But for a lot of things in the blockchain world, you can know how to use them in your application, right? And what a validity proof is essentially a way for me to execute a program, and then I send to you the result of that program along with a proof of execution. And now you will execute something else, which is a verification of the proof. And you have mathematical certainty that I executed the program correctly. You don't need to rerun the same program. Now, where these validity proofs are very powerful is that it's much cheaper for you to verify these proofs than it is for me to execute the computation. So there's an asymmetry between the person executing the payload and the person verifying it. The next cool thing is that you can verify these kind of proofs in Ethereum in a smart contract, right? And so you basically enter a new paradigm where you can do with execution what mining does to security. Mining is to security the network delegating to some specific service providers, you deal with security, you offer a service, but we can control that you're doing everything correctly, right? The miners are just supplying a commodity, which is security. Well, now validity proof allows to do the same thing for execution and smart contract execution. So that's what validity rollup or ZK rollups are. What StarkNet is a validity rollup. So it's an Ethereum-like network, right? It has blocks, it has transactions, it has accounts, and it executes parallelly to Ethereum And every now and then, the proof of transition of the state of StarkNet is condensed into a proof, and that proof gets sent to a smart contract on Ethereum. It gets verified by the smart contract on Ethereum, and that smart contract is in charge of saying, yes, the state of StarkNet is valid or not. So now you get execution on the side, but the security of the chain is maintained by Ethereum. Does that make sense?
Yeah, totally. Totally. That was a really, really good high level overview, actually. So breaking this down a bit more, okay? So people that have done a little bit of research into ZK know that there are like different kinds of proofs, right? There are Starks, SNARKs. Like, how do Starks and SNARKs compare with each other? And I guess my assumption is that, I mean, StarkNet is, Stark is actually in the name, right? So you guys went with like Starks. So if you could just like break down the difference between the two types of proofs and maybe what each of them are good for, I think our listeners would appreciate that.
For sure. With the ability we have to misname stuff in crypto, I wouldn't be surprised if it weren't the case, but you're right, StarkNet is based on Starks. So Snark proofs and Stark proofs are essentially two ways of doing more or less the same thing, meaning prove that you executed something to somebody without him having to re-execute it. Snarks are a bit older than Starks. I think Snarks date back to, do check what I say on that, but I think it dates back to 2014 when Starks date back to 2017, something like that. And at a low level, they use different primitives. So there are protocols for us to agree on, I executed something and you have certainty that I did so correctly. And one of the main differences is Starks rely on one cryptographic primitive, which is SHA-256, meaning the protocol is safe as long as you consider SHA-256 to be collision resistant. And SNARKs depend on SHA-256 as well as ECDSA cryptography. So as long as you consider these two primitive safes, then SNARKs are safe. So one of the implications of that is that SHA-256 is proven to be quantum secure, whereas ECDSA is not. So SNARKs are not quantum secure, and STARKs are quantum secure. So that's one difference. One other difference is that, so you remember when I explained I execute a program and I get the output as well as a proof. The proof for SNARKs is smaller than the proofs for STARKs, meaning that it's easier to verify a SNARK proof than a STARK proof. So that's one big thing. So that's why STARK proofs are in general relatively expensive to verify on Ethereum, and SNARK proofs are not. You can use a SNARK proof, for example. One of the biggest tool you use with SNARK today is called CIRCOM on Ethereum. And you can create a CIRCOM circuit and verify it, right? For a small unit of computation. Like, for example, depositing stuff in Tornado Cash. It's harder to do with STARKs because the proofs are bigger and much more expensive to run. And now the last thing where they differ is that SNARKs are hard. I mean, the work required to create the proof is bigger than the work required to create the Stark proof. So in other words, SNARKs favor the verifier at the expense of the prover, and STARKs are the other way around.
Interesting. Yeah, that's a good overview. I didn't know the bit on quantum security, actually.
Oh, one other major thing is that and I think it's due to the fact that they use ECDSA. SNARKs generally have the necessity for a trusted setup. Like, you need to have, when you generate a SNARK circuit, you need to have this elaborate, intricate ceremony where you inject some random entropy in the system. And then you discard that entropy. The issue is that if you don't discard that entropy, then you can compromise the system. So now what people do in general is have an elaborate system where a lot of people collaborate, and as long as one person is honest, then the system is not compromised. That's what happened for the KZG ceremony on Ethereum recently. SNARKs have a need for that. Starks don't. So, yeah, that's another major difference.
Zcash has a trusted setup, right? Does Zcash use
Zcash has
SNARKs?
yeah, it does. It uses SNARKs, yes.
Yeah. Interesting. Okay, that's helpful. That's helpful in kind of setting the stage here. So on like a tactical level though. So if I'm thinking about StarkNet and building on StarkNet as someone who's normally built like Solidity smart contracts, one of the things that I'd want to understand is how is a transaction actually executed on StarkNet? I know we talked offline and you mentioned that like things are going to evolve over time, but it might be helpful to just understand like what the life cycle of a simple StarkNet transaction looks like. Can you just walk us through like a simple like token transfer or something like that?
Sure. So when you send a transaction on StarkNet, so one thing is StarkNet uses account abstraction. I'm not going to get into that right now, but let's assume your transaction enters StarkNet and it starts and it gets executed. Where your transaction is really received by a service provider called a sequencer. The role of the sequencer is to maintain a mempool and then to aggregate transactions into block. So the sequencer will basically aggregate all of these transactions and update the state of StarkNet, and eventually is going to put a bunch of them in a block and say, well, this is a block. Then this block, after a certain period of time, will be sent to another entity called the prover. The prover will take the content of the block and then re-execute it in a special paradigm where it will be able to generate a proof of execution. So it will basically take the output of the block and say, yes, this is correct, and here's the proof for that, right? Then this proof, as well as the state diff of the state of StarkNet, right, is sent to Ethereum to a smart contract. That smart contract will take the proof, verify that it's valid, and then it will also check that it received all the data that is supposed to have received. So, like state diffs of StarkNet in the case of a ZK rollup, and messages attached to the bridge, so data messages that allow executing payloads on one side or on the other side. So essentially, and I'm this is a general presentation. There's how things are now and how things will be in the future. Right now, the sequencer and the prover are maintained by StarkNet. So when I say a sequencer, right now it's a server we operate. And when I say a prover, right now it's a server we operate and we send the proof. Now, eventually this will get decentralized. And so you will have a consensus mechanism for leader election for the sequencing part. So various sequencers can sequence blocks, and they'll take turn building blocks, and then eventually they will be sent to provers, but there may be various. The exact protocol as to how do you distribute the role of the prover and what is the frequency you send the updates to Ethereum is yet to be defined. We're researching that right now to see what makes sense and how we can try to make something cool. But right now, proofs are sent on testnet every 2 hours, on mainnet every 12 hours, and as usage pick up, these proofs will be sent more.
Nice, and I appreciate you highlighting like the because I was thinking about asking about how centralized the sequencer is right now because that's typically how most of these things begin. But I think you guys are in an honest position where you're like, hey, progressive decentralization is what we're doing here, and this is really complex stuff. Is that right?
It is, and I think it is absolutely. But I also like taking a step back. I think decentralization has many dimensions. There's the network architecture, obviously, who gets to operate the transactions, but there's also the code licensing, who can execute it and who's allowed to fork it. There's also who develops the software, how many companies are in charge of maintaining this infrastructure. There's also who gets to decide on upgrade. And I think decentralization is way more than just who runs the node. And we're working on all these fronts, and it's also really interesting.
Absolutely. Yeah, I think different protocols approaches it in different ways, but I think you guys are doing a good job. Okay, you mentioned account abstraction. We won't make this whole episode about account abstraction because we've done a couple of episodes around it. This is actually how we got connected through Julian from Argent. He was a big proponent of what you guys are doing, but like, how does the account model work on StarkNet, and like, how did you build account abstraction into the protocol? Again, we don't have to talk about it for 20 minutes, but it'd be good to get an overview.
No problem. Well, so I see the account abstraction is weird because when you come from Ethereum, it's kind of counterintuitive. On Ethereum, you have a transaction, and a transaction pays for its gas, and it always have an owner. So how can you have a transaction that executes a smart contract without having an owner and somebody that pays for gas? It was very counterintuitive to me at the beginning. So the way we went around it is basically by following EIPs that were done by the Ethereum community, because if some people have good ideas, why reinvent the wheel? So we went after EIP 4337. And the way you can imagine it is the following. When you send a transaction to Ethereum, it actually has two steps. There's one step, which is the verification of the transaction, right? So you verify that somebody signed for that transaction and somebody is willing to pay for gas, right? And that verification is done in Geth or whichever client you're using. And if the transaction doesn't validate this, then it's discarded. And then it enters the EVM and it executes smart contract, right? So the validation of the transaction is outside the EVM. Well, in StarkNet, the validation is inside. That's it. That's how simple. So basically, the validation part, instead of being outside the virtual machine, and instead of being the same for everyone, it is inside the VM. It's part of a smart contract, and you get to decide what you want for the validation of your transaction. So validating your transaction it has a few quirks. So it's like it's in a bounded environment. You can't touch the state of everything. You're limited in the amount of complexity you can get in these stuff, so that you don't toss the sequencer. But essentially, that's this. It's just moving validation from outside the VM to inside the VM.
Interesting. Yeah, that actually really isn't as complex as I thought it was going to be. It's fascinating that I was talking. We had a conversation with one of the founders of Sway, like I guess Fuel and Sway, and they do the same thing where they look at old EIPs and they're like, let's just implement this, right? Because you guys and Fuel and some of these other new environments, you don't have the baggage of years of build up and lots and lots and lots and lots of opinions, and you're able to move a little faster and implement good ideas more easily, actually.
I mean, it's the benefit of hindsight. We're standing on the shoulders of giants, Bitcoin, Ethereum, and a lot of other people on the side. So we get to see things they wish they had done differently. And, if in a few years, other people building great tech look at what we do and say, maybe let's do this differently, and the benefit from the errors we're currently making, because for sure they are, and we're not realizing it yet, then that's great.
Yeah, I love that mindset. And one thing you mentioned as you were talking about this is that coming from like an Ethereum or Solidity developer background, how account abstraction like works and thinking through it is actually kind of counterintuitive. What other things about building on StarkNet do EVM devs need to keep in mind? Like, what different mental models and things what kinds of things do they need to keep in mind, and what kinds of new things do they need to learn and get used to in order to be really effective in building on StarkNet? Outside of maybe Cairo, we'll talk about Cairo, but more general things.
That's a great question. So one thing is what we discussed earlier, like the life cycle of of your transaction. What the finality of your transaction? In Ethereum, you send your transaction, it's in a block, and then eventually it gets finalized. On StarkNet, it gets into a block. It's secured by StarkNet consensus. Then it is sent into a proof to Ethereum. Then it is finalized, right? So there are more layers toward finality. That's one thing. Aside from that, the VM is actually really similar to the VM you have in the EVM, right? There's state, it's account-based, there's smart contract code. There are a few differences that are, I'd say honestly, kind of minor. So a smart contract on Ethereum is state, an address, and code. A smart contract on and nonce. And the smart contract on StarkNet is state, an address, a nonce, and a contract class hash, meaning that we dissociate contract code storage and an actual contract. So two contracts that use the same code can mutualize it, right? They can point towards the same class. That makes sense. But that's minor. It does have an impact because when you deploy your contract, you don't just deploy your contract. You have to declare it first so that the class gets recorded and is available in the OS, and then you can deploy your smart contract. And aside from that, honestly, I think the biggest thing to know if you get into StarkNet right now is that it's moving very fast. And so the mindset you need to have is really one where you're proactive and looking out about update. I strongly encourage you to get more, like to get involved in the community, to talk with people, to participate. And this goes in two directions. The first one is for you to know when upgrades are coming and when things change, and it happens quite a lot. And the other thing is for you to voice your opinion, because we're building this thing as we go and we need feedback. We need people to tell us, hey, this is a major feature for me, so I need this, or hey, this doesn't work, or any kind of feedback, really. We really need people to tell us how they use the network and how we can make it better. So yeah, I would say this is a big thing. Like it has less of a user perspective from a dev. You're less of a user of a network and you're more of a member of a network, right? And of a community. I'm not sure if that makes sense. It's not very technical, but I think it's worth underlining because like it can be surprising for people.
That's interesting. I mean, that's probably just a function of the stage you're in, right? In 10 years, it's probably going to be it will probably be, things will be more ingrained. It'll be probably less like collaborative on a day-to-day basis, like in terms of implementing new features and stuff. But I think it's
For sure, for
interesting.
sure.
It's interesting you can approach communities like yours and have that impact, right? And I don't think everybody necessarily realizes that they can go out and they can shape new ecosystems if they're really smart and really good at what they do and willing to go deep. Um, and some people that I know have decided to do that, and I think it's rewarding for them.
So one other thing that I would one other actually major difference with Ethereum is the price of things, essentially. So when you're on a ZK rollup, some resources are priced differently than when you're on a L1 blockchain. So for example, compute is very cheap. Since you're able to delegate execution to specialized actor, they can afford to operate the network on a supercomputer or on a machine on which they have a lot of economies of scale. So computation, making calculation is cheap. By the same account, but not for the exact same reason, but since you have a proof that allows you to get in sync with the state of the network and you don't need to replay all the transactions, you don't need to store all the call data for all the transactions to recompute the state, meaning that call data is virtually free. Like you can use a lot of call data in your calls because it doesn't need to be kept at the network level for the network to be safe. And the other thing that is a bit counterintuitive, though, is that not everything is free on a ZK rollup. And one thing that is expensive is storage. So there's a small, maybe we can talk about data availability later if you're interested in it. But let's just say that right now, the state of StarkNet is recoverable through Ethereum. And since it is sent to Ethereum, it's not free. And when you store a storage variable in your contract state, it's relatively it's expensive. It's less expensive than on Ethereum, but it still has a cost. So storage is expensive, compute is cheap, call data is free.
Interesting. So I usually ask this question toward the end, but like based on some of these different properties and different different pricing of certain resources, like you mentioned, are there certain applications that you think are possible on StarkNet that aren't possible in different environments? And if so, what are some of these things that might be enabled by this new environment?
Yeah, that's a great question. And I think to me, what I like about StarkNet and this landscape is that it's really hard to predict where this thing will go, right? I mean, when you give computation power to devs, where can this go? People's creativity is limitless, so there's a lot of things you can do. One thing where we see a lot of people get interested is, for example, for things revolving around gaming. Because when you have a Web3 game right now on an L1 blockchain, compute is quite expensive, so you can't do much with your game. You can't put a lot of the gameplay on it. You can put the accounting of the game on chain, but you can't put a lot of the gameplay. With a ZK rollup, you can have a lot more gameplay actually be computed on chain. So that's something that's really cool. Another thing that's really interesting to me, and it's an extension of cheap computation, is something we call storage proof, which is essentially a way for you to copy paste the state of another blockchain trustlessly into another one. To think about this way, let's say you and I want to exchange Bitcoin and Ethereum, right? We want to do an atomic swap. The way we could do that is I lock my Bitcoin on a specific transaction, and you lock Ethereum on a specific smart contract, and I lock my Bitcoin in a specific script. And if I lock it in the proper script, you can unlock it only if you publish a secret that allows me to get this to unlock your ethers on Ethereum. Now, the issue with that is that you can ghost me. You can basically decide to never tell the Ethereum contract that I disclosed that I deposited the Bitcoin on Bitcoin, and then I'm effectively stuck, right? The issue with, and so the way you solve this is that I should be able to prove that this happened on Bitcoin. And the issue with that is it's really hard it boils down to the Oracle problem. It's really hard for me to prove to Ethereum that something happened on Bitcoin because it's akin to running a light client inside a smart contract on Bitcoin. And this would be very expensive on Ethereum. Now, the cool thing with ZK proof is that you can basically take the state of Bitcoin at any point in time, or any other blockchain for that matter, and you can prove that is correct. And with this proof, you can use it on StarkNet. With this proof, you can prove that something happened on another blockchain, and then we can basically have atomic swap. Sorry, I don't feel like this explanation is very good, but essentially, since it's deep computation, it allows you to take a specific area of state of a blockchain you're interested in, and then just have a bunch of verification that can say, yes, in this blockchain, at that particular slot, this information is written. And there's a lot of really fun stuff you can do with. So this is very useful for token voting. Snapshot is using it for Snapshot X. And I'm looking forward to somebody implementing some kind of vampire attack with that. You can basically steal somebody's user base by airdropping them a bunch of stuff cross-chain.
That's fascinating.
Does that make sense?
I think it does. So it makes sense. I'm picturing like a Thorchain style application built on top of your technology, right? That's kind of what I picture. But in terms of how about like privacy, like preserving protocols? Let's say that I wanted to deploy some kind of privacy preserving DeFi application on StarkNet. My assumption is this is possible, right? Like how would I go about doing that?
Yeah, that's to me, this is one of the most interesting thing and direction we can go on StarkNet. But right now, like, it's not currently very possible. The reason for that is that if you want to have a privacy preserving application, you have to use zero knowledge proofs, right? And if you want to use zero knowledge proofs, you have to be able to verify them on chain. So we would have to be able to verify proofs on chain. And for that, you really need two components. First, you need a verifier on chain. And some community members are working on it for StarkNet. It's not available yet. The other thing is you need a prover. And right now, there is no Stark prover that is available. So let's split it into two branches. If you want to build a privacy-preserving application, you could decide to use StarkS or SNARKS, right? So for SNARKS, there are a lot of provers that are outside, but there is no verifier on StarkNet yet. For StarkS, there is no prover that is easy to use, and the verifier is not yet fully implemented, right? So, and these are the most interesting building blocks, I think, because aside from privacy, they allow a lot more fun stuff at the network level. But like for privacy preserving application, I would advise people to work on the design of their application. Look up a research paper on how you build privacy preserving application and try to implement these things in code, these protocols. And eventually you'll be able to prove them on StarkNet. But right now, the tooling is just not there yet.
Gotcha. Yeah, I think the initial use for zero knowledge proofs in the space is actually like scalability, right? Which is really what you can get out of building on StarkNet in the first place. And eventually, I'm sure people will build these privacy preserving things all over the place. Maybe not just on StarkNet, but it sounds like once some tooling is available, they'll build that there too. But
Yeah, maybe get into Noir,
yeah,
the ZK language by Aztec, which I hear is really great. And eventually Noir is going to be settled. I mean, it is going to be usable on StarkNet for sure.
really, that's really interesting.
I mean, I say for sure, not in the sense that I have certainty that this will happen because we're working on it. I wish we were, but to the best of my knowledge, it's not possible yet. Basically, in order to be able to verify SNARKS on StarkNet, we need to be able to do a bunch of complicated operation related to ECDSA cryptography, specifically signature pairings. And right now, they're very expensive to do in a ZK environment. So we have community members working on that, and I think it's an extremely important primitive. But once we have the ability to do these pairings and verify SNARKs, well, I mean, you can use Circom on StarkNet, you can use Noir, you can use all the existing SNARK tooling. It's just a matter of porting them. Just
Interesting. So on the topic of domain specific languages for zero knowledge rollup environments, right? Like, can we talk to Cairo? Like, why build Cairo in the first place?
Sure. So Cairo is a byproduct of us trying to scale stuff, essentially. Um, when you take the genesis of StarkWare and Stark proofs, essentially Stark proofs in their at their essence is about me proving to you that I know a bunch of solution to a polynomial with, let's say, 1 million factors. And I'm able to prove that I know a million roots without you having to verify all of them, right? And just like you can encode computation on transistors with Boolean logic, you can encode and you can encode computation on polynomials. And so starting from that point, we started thinking, okay, so what can we do with that? And so we started crafting this. We started taking a problem. So in the first case, for example, trading at scale, and we started crafting these specific equations and polynomials that would fit just the right problem, right? And it took a lot of time and effort, and it was not very flexible. So you can figure this out just like it's similar to building ASICs, right? Specific ASICs where you have application specific integrated circuits. And this worked well, right? We built something that allowed you to trade ERC20s and settle on Ethereum. But it wasn't very flexible and it was hard to upgrade. So eventually, from these circuits, we built a bunch of tooling to make this better. But after a while, our engineers said, "Hey, maybe instead of doing ASICs, why don't we try to build a CPU architecture? Because CPUs in your machine allow you to do general computation." And so they crafted these specific set of polynomials that allow you to mimic, or better, to implement a CPU over polynomials, meaning that every operation that you execute over this CPU is provable, right? And that's what Cairo is. Cairo stands for CPU Air. Remember these ASICs I mentioned earlier? We call them airs for algebraic intermediate representations. Cairo is CPU air. It's basically a set of polynomials that mimic a CPU. And so that's the Cairo architecture. And then on top of that CPU, we had a language that started to emerge, right? We in the beginning it was assembly, Cairo assembly, and then our engineers, being good engineers, were lazy. I shouldn't say that; they will get pissed at me, but no problem. So they decided to abstract away part of the complexity and to make it easier to understand, right? And then eventually we figured, well, if we're able to use it, why shouldn't other people be able to use it? And we started working on StarkNet. And we basically say to people, hey, you know what? If you want to write verifiable subroutines on StarkNet, you can use this tool we developed, which is Cairo. And that's how Cairo came to be. Does that make sense?
Yeah, absolutely. And you have a lot of really great, like, beginner to advanced examples in your docs. I mean, you take people all the way from like first function to a simple AMM, right? So you have great docs. But you said offline, actually, before we started recording, that Cairo has been evolving over time. It's evolved a lot, and it's going to continue to evolve. So, like, what's like the backstory? Like, how has Cairo evolved to date, and how do you see it evolving in the future? Like when I ask people what I should ask you, in this conversation, the thing that came up every time was Cairo 1.0. We don't have to talk about like the specific syntax in Cairo 1.0, but I think people are curious about like what the evolution's been and where the language is going to go.
Yeah. Well, if we take the same analogy I took before, so we went from ASICs to CPU to being able to write assembly code on CPU to being able to write something that executes on the CPU, right? It's not assembly, it's kind of like assembly, but not exactly assembly. The issue with Cairo 0 right now is that it is not made for an adversarial environment, meaning that if you write code that fails in Cairo 0, it's impossible to prove that your code fails, right? You can prove if it executes correctly, but if it fails, you can't prove it, right? Which is very problematic in a blockchain environment. Like, what if I could craft an Ethereum transaction that fails and you could never prove it? I would spam any validator I want, and they could never charge me for gas, right? And so going back to the CPU analogy, it's kind of like if you had the ability to run, you had a CPU anyone could run code on, but if there's an error in their code, then the whole CPU freezes and stops. That's obviously problematic. You want your CPU to be able to handle errors better. And so in that quest, we came up with something we called Sierra, which stands for Safe Intermediate Representation. And Sierra is essentially an intermediate language that compiles to the same Cairo assembly, so Chasm, right? So you have Cairo 0 compiling to Chasm. You have Sierra compiling to Chasm, right? The CPU doesn't change. But this Sierra representation, by design, can't fail on the CPU. So errors can always be handled at the CPU level. And what Cairo 1 is essentially just a new compiler from a high level to Sierra to Chasm. So that allows us to come up with a brand new language that is safe because you can prove that execution failed. So if somebody sends a failed transaction, we can prove that it did, and it works better in an adversarial environment. And so in that process, the language has evolved a lot. And you can kind of see it as on Ethereum, the migration, like in the beginning, there was Serpent, which was a very basic language for Solidity, for the EVM, and then Solidity came. Well, Cairo 1 is kind of this. It uses the same architecture underneath, but it's a new language. And that's what Cairo 1 is. So we're right in the middle of rolling this out on the network. I can talk about this transition period also if that's something that you're interested in.
Yeah, no, that's very interesting. So you mentioned like Cairo 0, like before this, like Cairo 1 was not necessarily built for adversarial environments. And I think on the topic of adversarial environments, like something that people think about all the time is security. So a lot of people that are Solidity developers Like a lot of them either have ambitions of becoming an auditor one day, and pretty much everybody wants to get better at smart contract security. So, like, how do you and the StarkNet team and community think about security when building Cairo contracts? Like, are there any specific things that are different about building in Cairo that you need to keep in mind? Like any like specific foot guns or landmines that somebody that's not as experienced with this environment can step on when first building in this ecosystem?
I think that there are a few, but essentially one of the first is that you can't use. I, I don't know if these are like very specific things, but let's try. Um, so one of the thing is you can't use signatures the same way you use them in Ethereum, meaning that in Ethereum you can associate and identify a user with a signature from its account. In StarkNet you can't really, because every user is a smart contract and a smart contract can't sign stuff. So that's one small thing. The other thing revolves around upgradability. We're actually right in the middle of this debate, but we initially went with, smart contracts are immutable and you will use the same proxy pattern as Ethereum. We're now reconsidering this because for a transition period that I mentioned before from Cairo 0 to Cairo 1, we're going to need to allow contract to update basically the class hash they refer to. So, and this ability will basically void any necessity to have upgradable proxies, right? Well, you'll have upgradable contracts, but they're not going to be proxies anymore. So the whole proxy pattern will change, and that's something that is quite different with Ethereum. And aside from that, state is not kept the same way. Basically, your contract variables are not addressed the same way as Ethereum. So if you need to think about how you store data in your smart contract, particularly when you do an upgrade, you need to be careful. It's different on StarkNet and on Ethereum, but I'd argue it's a bit simpler to understand on StarkNet. So yeah. And aside from that, like for a security concern to not shoot yourself in the foot, I think for ZK rollups, the bridge is an intrinsic part of the design and is a really important one because it's not just a bridge for assets, it's a bridge for data, right? So, and with that brick, you can really start thinking about layer twos not as a separate environment where you get a clone of your application, but as an environment where you get an extension of your application. And it's just an extension of your application on L1. And having this kind of asynchronicity gives the opportunity to have really interesting patterns in how you design your application, but they're not very well explored yet, right? This is all very new. So I think there are a lot of pitfalls there, but I don't know where they are yet because nothing has been like this is still being built. So I think like being very careful when you build your bridge is an important thing.
Yeah, that makes a lot of sense. That's a question I always like to ask is just people, our security minded folks tend to get into that sort of thing. But one other question. So I'll ask one more question on like technical implications of StarkNet, and then we'll get into maybe some more tactical things for people that want to actually build on top of StarkNet in the future and like maybe what they should focus on. But one thing you and I discussed before we jumped on was this this idea of like what the effect is of having provable computing on the topology of validity rollups. This is something you wrote up in an email to me that I think we should really unpack. But can you expand on that question and maybe give some of your thoughts there?
Sure. So we discussed earlier that the fact that blockchain networks on L1, you need everyone to redo the same work, and you need everyone to have access to the same data to reach the same common state of the world, right? It means that everyone keeps the data, so there is no worry. As long as the network is up, the data is somewhere, and it is kept by someone, right? And by default, you can assume every user to have a copy of all transactions. So the role of a node is fairly well identified. It keeps the historic of the network and it keeps the list of transactions. In a validity rollup, you don't really have this necessity. You can take the latest proof as long as you have the state. You don't need to have the list of all transactions that's happened in the past. And I think that there's a lot of directions you can go into that, but I think this is great for light nodes in the sense that, imagine you're an application today running on Ethereum. You need to run a full node to serve the front end of your customers. What do you need this for? You need to have access to the state, and probably you'll want to give them a vision of everything they did with your application before. So you will need the events. So that means running a full node to have access to all the events that happened in the past as well as the current state. Well, in the ZK rollup, you don't really need that. You can have access to the latest valid state just with proofs, and events are part of the proof, so you can extract only the one you want. The question being, if I deploy a smart contract and I vanish for 10 years, who keeps the data of my contract? What is the incentive to do so if you don't need it, right? And so I think that part of it is linked to the data availability problem, but I think that we will see a big question around what it means to be a node in a validity rollup, because you won't have the same necessity, you won't have the same task, and you won't have the same capacity. On the one hand, it's great because participants with much lower capacity will be able to interact with the network. But on the other hand, a lot of assumptions that are baked into the blockchain right now, the blockchain world, meaning data will always be there and I'll always have access to it, are put into question. Though I think, the more I think about it, and the more this is also a question for L1 networks, but it's.
So wait, how do you guys think about data availability in this environment then? Like, is it, if you only need the most recent proof, what's is the point of having it just out of purity for the network? From an ideological point of view, we want to be able to access every transaction that ever happened in this.
Do we though? I mean, that's I don't know. Let's and I say we as users, do you care that much about all the transactions that happened on PancakeSwap a while back in order to run your own node? I don't know. Now, from the perspective of the network, the truth is, I don't know. Right now, StarkNet nodes keep all transactions, but I think that this is an assumption we should debate. Should they? Should they not? Is the only thing that matters is state? When you think about a node, what really matters is just that it knows the state is valid, and it doesn't need transaction for that. And requiring transactions puts a big load on the participant. If we want a more diverse network, probably getting rid of transactions is the way to go. Now, some players for sure will run indexers, and some players will collect all transactions because, hoarders, right? Hoarders of data. And so they will just take everything, and who knows, maybe one day it will be useful. And maybe one day they will monetize this data. Maybe not. It's I'm not sure. I'm not sure how where this will go, but I think it's an interesting area to ponder.
Yeah, it's an interesting debate for sure.
And sorry, your question was specifically around data availability. So right now, StarkNet is a validity rollup, meaning that all the state of Ethereum is kept. I'm sorry, all the state of StarkNet is kept on Ethereum. The reason for that being that the proof of transition from block 0 to block 100 is valid by itself without giving the state diff. Ethereum can interpret it without having the state diff. But if it doesn't have the state diff, then there's the data availability problem where you could basically have a sequencer that moves the state from state 0 to state 100, vanishes, and then everyone is stuck at block 100 because nobody has access to the state. So in order to avoid that problem, we require every state diff to be published on Ethereum. There's a downside to that. It's quite expensive. So some people are exploring a design called Validium, and some projects using StarkX use the Validium mode where the data is kept off-chain, but the proofs are still valid on Ethereum. Where we're going with StarkNet is probably somewhere in between that we call volition. And essentially, the first design we have will be that in your contract, you will probably have the ability to declare your variable either as being on chain or being off chain. And off chain will have granularity, meaning that you will be able to select various data availability solution, right? Um, for the beginning, we'll go with one option only, which is that this data will not be sent to Ethereum, but will be kept by StarkNet nodes, right? But eventually, we can think about adding other data availability solution, and there are a lot around. So we'll see.
That's really interesting. That's really, really interesting. Yeah, we'll see how that debate evolves over time and how, I guess, like the network evolves over time as well. But as we wrap up here today, because we're running a little low on time, uh, two final questions. One of them is tactical, one of them is a little more broad. But for all the devs listening to this that are considering jumping into Cairo and the StarkNet ecosystem, what do you want people to build? Like, what kinds of things would you like people to work on uh, in your ecosystem?
Um, so there's a lot of things. So I think three things come to mind. The first one is if you're a dev and you used Ethereum or a L1 blockchain in the past and you feel like I could use more computing power to do X, Y, Z, and this can be whatever you want, right? This, I want you to be able to explore that. I want you to see what you can do with more computing power on a blockchain network. That's something I'm really interested in. That's one. Second is what we discussed a bit earlier. You have an application on L1, and probably if you have an application on L1, your objective right now is to try to go to as many sidechains as you can, right? You want to go to other EVMs because it's easy to replicate, right? You just roll out to another chain. The thing is, integrating new EVM chain as diminishing return, because you'll first go with the one with biggest liquidity, then when the second most and third most, and so it will decrease over time. And eventually, you just clone your application everywhere, but you don't make your application richer. Now, I want you to look at the bridge, look at StarkNet, and figure what can I do to extend my application? What can I do with the L1 liquidity, the one on Ethereum? What do I wish my user were able to do, and how do I enable them to do that through an L2 trustlessly, totally non-custodial? I think that's a really interesting area, and we're seeing teams as Aave and Maker think about that. So I think that's a really interesting application. And then there's a third thing you can get into is maybe you're a math wizard, maybe you're really good at infrastructure, maybe you're really good at networking. Take a look at what StarkNet is today and find out the glaring holes. And there are a lot of them. There's a lot of tooling missing. There's a lot of things we need more brain power on, and contribute to that. Like start building infrastructure, start building tooling. There are a lot, like it's not just StarkWare developing StarkNet. There's a bunch of other companies involved in making the network evolve and upgrade. And we want more people doing that. So if you're into that sort of stuff, if you're into building clients, indexers, infrastructure, get involved here.
Nice. Yeah, it's a good call to action for people for sure. I especially like the idea of exploring what you could do with more computation. People listening to this point, they'll recall our conversation about that earlier on. But awesome, man. So, final question: if we zoom out and we look at like what you would like crypto to be, like what Web3 should be, like where do you think our industry should go in 10 years? Like, what do you hope if you were to close your eyes and wake up in 2033? What do you hope we would have accomplished by that point?
I hope we have something that is used by more people than is used today. Like to me, that's really the bottom line. Are we building something that gets used? And whatever that may be, whether it's NFTs, ordinals, or DeFi, whatever that is, do we manage to reach out of our little circle and make all of this more accessible to people in general? The more, the better. Um, like to me, this is like the main thing is like, are we doing something that other people use? Because if a tree falls into the forest and no one hears it, did it really make a sound? If we build all this amazing tech, but nobody uses it, is that really good tech? So I think that getting more users generally is what I want us to do. And I don't have a specific direction in mind. I'm fine with whatever that is. I hope we do get to in a direction where we get more self-custody, more empowerment for user, more privacy for sure, easier to use. So yeah, essentially, does that make sense?
Yeah. Yeah, it's a great answer. So where can people find you online? Where would you like to point people that listen to this conversation?
Sure. So me, probably on Twitter, my handle is HENRLI twice, right? That's me. Now, if you want to learn more about StarkNet, you should check out the StarkNet handle, StarkNet. And if you're a dev and you're looking for educational resources, I'll point you to our StarkNet edu repo. So it's github.com/starknet-edu. There's a bunch of tutorials there where we try to gamify them to make it more fun to learn Cairo. There's one specific thing I want to talk about, which is we have a program called Basecamp, where we take devs from the very basics of mathematics necessary to learn the Stark protocol, right? To what Cairo is, the CPU architecture I talked about, to what StarkNet, the network, looks like, how its architecture, to writing really cool smart contracts with state-of-the-art tooling. So if you're interested into that, you can do it by yourself, or you can join a cohort. We're going to try to run a bunch this year. And if you liked it, just run your own cohort, learn with friends.
I love it. Yep, I'll be sure to link to all that stuff in our show notes. But yeah, Henry, look, this was a fantastic conversation. I learned a lot, and I think people will as well. So thank you for coming on.
Thanks for having me, Sam.